Welcome back, everybody. So let's talk a little bit about Chapter 7 as I'm passing out these guided notes. Now, Chapter 6, Chapter 6 was kind of like two parts. The one that we just did was all about sequences, right? All about patterns in numbers and how we deal with patterns in numbers. But the beginning part of Chapter 6 was all about exponents and exponent rules and exponential functions. Okay? What we're going to be looking at in Chapter 7 is more on what do we do when we have numbers in an exponent? And what type of functions can we create when we keep the number in the exponent? Because we put an x in the exponent and we call them exponential, right? If we put an x in the exponent, we call it exponential. If we keep a number in the exponent and keep the variable down below, we call them polynomial. We call them polynomial.
I know this is off topic, so I apologize. Okay. But how is recommendations for geometry honors working?
That's something that you should talk to me about. But this is just the statement I give. Geometry honors is an extremely hard class. I would say to be considered to do it, you have to have a 95% or higher in all 9 weeks, including exams.
Okay.
But if that's something that you think you want to do, that's where we start baseline. Okay. But again, if that's something you want to do, come talk to me about it. I do have to recommend for that. Like, you can't get in that class. It's not going to be open for you unless I put it in the system for you. Okay, so adding and subtracting polynomials. Now, the first thing that we have to talk, it's funny, this is called adding and subtracting polynomials. We really don't get to start adding polynomials until like 3/4 of the way through this lesson. Most of this lesson is about what the heck is a polynomial, what is a monomial, what is a binomial, what is a polynomial, and how do we talk about it, and what are the unique characteristics of it. A lot of the things today, we're just going to scratch the surface of, and it's just going to be very introductory stuff where I say, okay, you're going to learn about what it is, but not learn about the implications until you get way later on. All right, so let's start small here. If you want the most basic polynomial, it is called a monomial. The prefix mono, meaning one, singular, one term. A monomial is a single term polynomial. One term. It could also be just a number if you wanted it to be. Like 5 is a monomial. Just the number 5 is a monomial. Just the letter x is a monomial. Negative 7xy is a monomial. Yeah, it could contain two variables if you really wanted it to. 0.5x to the 4th. That is another monomial. Here's our some that are not monomials. Because by definition, it's got to be a positive whole number exponent. Okay, negative exponent, not a monomial, because technically that would shift it down to the denominator, right? Negative exponent. So that's not a monomial. It's actually something different. It's not a polynomial function. It's actually what we call an inverse variation or a rational function. Same thing with 2 over x to the 3rd. Notice how 4x minus y, you notice how if I put a minus y in there, it separates those two things? That's two terms. That is no longer a monomial. We would call that what's called a binomial, and we'll talk about that in a second. The degree of a monomial, now this is important, and I want to make this distinction. I'm talking about only the degree of a monomial, single term. There's different rules to play by if you talk about a polynomial. This is just a monomial. The degree of a monomial is the sum of the exponents of the variables. Sum of the exponents of the variables. What does that mean? Okay, sum means to add. So I'm going to add up the exponents of the variables if I want the degree of a monomial. A constant has a degree of 0, and we'll talk about that in a second. So let's do a couple of these. Find the degree of this monomial. Okay. Do you notice how there's no addition or subtraction signs? Mm-hmm. That means that this is a single-termed polynomial, a monomial. Okay. So that means the degree is what? The sum of the exponents of the variables. The sum of the exponents of the variables. Gio?
7.
7. Good. The degree here is 7. And you'll see me write it as a D, sometimes DEG equals. Basically, it's just a number, a unique number to that monomial or polynomial, whatever it may be, that describes it a little bit. And again, you'll learn once you get further into algebra what that number means. You have no idea what it means right now. You're just here to identify it. But the degree is 7. How did we get to 7? Well, I see the power of 4 and the power of 3. You take the exponents of the variables and you add them together. That's where we got the degree of 7. What about 7 ED? What's my degree there? To be a 2. Because this is degree of 1, degree of 1. So the whole degree is 2. Now, let's take a look at this. You know what's funny? I asked this last grade. I said, what's the degree here? And somebody it said, oh, well, it's either 3, 1, or 0. And I said, yeah, those are pretty much our 3 options that somebody would give me. It's either 3, 1, or 0. Now, let me ask you this. I'm going to throw out 3 right away because that's just the value of the number. Did 7 or 4 play a role in the degree up here? No, so 3 is out the window. So it's either 0 or 1. For it to have a degree of 1, it would have to look like that, right? For it to have a degree of 1, it would look like that. That's not the same thing. Was there ever a variable there even? I added in this x. What would I put on the power of x to make it go away? 0 power. And that's why the degree here would be 0. Okay, because it's a constant. It's just a number value. So therefore, the degree of this would be 0. The reason being is for any number, just a single number, you could put in a variable to the 0 power if you would really want to. Okay, and what if I made it really crazy? What's my degree of that monomial?
Would it be 9?
It would be 9, yeah. Because we have a 3, a 5, and a 1. 3 plus 5 plus 1 is a 9 altogether. So the degree of 9 here. Yes, sir?
Who's the Fred James?
Oh, we want the academic challenge from it. Yep. What's that? Lake there. We want a, you want to see the trophy?
Yeah.
The glass bowl. Actually, you know what's funny? The last time we had this in 2018, I had it on that shelf over there, and people were like milling about at the end of the period, and somebody knocked it over with a backpack.
So that's why it's in a box.
That's why it's in a box. I'm gonna put it in the trophy case. Here it is.
You're gonna put like a trophy or something.
What do you do with the bowl?
It's not true.
I'm gonna put it in the trophy case downstairs.
Why is it a
That'd
bowl?
be like a good party bowl.
Can
for, like,
you eat out of
display.
it?
Put a fish in it?
Put, like,
Hey,
Yeah,
what-
I'm gonna put a fish in it.
Fish bowl.
I'm gonna put a fish in
Some
it, right?
Doritos in there or something.
No.
He's using it as a super
Monitor.
That's good.
I could literally go buy that at like.
What are the other trophies?
Well, see, the thing is, that glass bowl rotates around to all the, like, you only get that for 1 year. So like next year, whoever wins the tournament will get that glass bowl.
What
for
if
the
you
year.
break
No, I
it?
mean,
So
Like,
these,
I can go to
so
the store.
shh. That's kind of an expensive thing.
What if you break it?
Yeah.
I had to buy. I know we broke, and I had to buy a new one out of our guts. $150. I know. Pretty expensive.
So that's
right?
what you
bought?
I had to like Google search like glass bowl
I can make a
trophies.
replica. Like
Well, you
that.
can put a goal in your fish in it.
Why don't you just
Yeah.
go to the dollar store?
So you
Right, because that would be a really official looking. But they give for one to keep. They do like I'll get one of these in about a week or 2. So I'll add that.
The sticker residue.
Well, just the tall ones are first places. These ones are second places.
Wow.
So you got to keep those.
I've never won a third. This is a fourth.
No.
I've never gotten third.
You're just like.
I've gotten first, second, and fourth. Never got a third.
So you got your
Oh, these ones? These are from. You ever watch the academic challenge TV show on Channel 5?
No.
Oh.
No.
Sometimes on TV they have a.
Did they know that you broke the mold?
Yeah.
Oh, I would just like once before, you know what I mean? Like switch it in. Like
Yeah.
this is the sick
He
mold.
gives it back to Henry.
Yeah, this is how I found it.
Did you slip the guy?
It
Wait.
falls in.
Who won last year?
Like fighting over the
No.
Who won last
Last year it was Glen Oak.
What?
Yeah, Glen Oak's academic challenge team is very good.
Math.
Because they got like the top first.
Because I'll tell you what, you think about Glen Oak School District goes from, like, it butts up against Mount Pleasant, all the way down to Canton, all the way over, and it neighbors Jackson over there too. So, like, Glen Oak School District is giant. So they have a lot of kids to pull
Is
from.
that like the first ever?
They have a lot of
Their first ever?
Yeah.
Put my name on the Like, Lake is only on here once.
Oh man, is that from this year?
No, that's 2018. We gotta get it.
Who won
So you
most?
just-
Who has the most? Glen Oak or like?
Jackson. Has to be
I'm
Jackson.
probably on the
Or
wrong.
keep it special.
It's gotta be the Hoover.
Glen Oak is huge.
Okay, so this is 1, 2,
Guys,
3,
we're
4,
like
5, 6,
Look at that.
7 Hoovers, 8 Hoovers.
It's like, they said it's like a college campus.
1, 2, 3, 4.
Who's on there the most?
Is Perry?
Oh, Glen Oak is only 4.
So Hoover's got more. Is Jackson
Hoover.
ever won?
Central's on here a couple times. 1, 2,
CCHF.
They've only been on there 2
That's
times.
3.
We're getting glass bowl for that.
Central is only 3.
Central
We
Catholic.
have to pass around next
Jackson is
Sometimes we don't win.
3.
Yo.
So
Give it
Glen
to
Oak
the
has the
school
most.
next year with a
No.
fish inside.
Hoover owns that box.
They own
We'll take it down eventually.
Is it like heavy?
We're gonna fill the rest.
Yes.
Yeah, we gotta bring.
It looks like
some
a
plant
pot
or
something.
No. Let's get back to it, shall we?
With a tree in it.
Throw like.
We should give it back with a planted tree in it.
Right.
That'd be fun.
It'd be like
It'd be like the
Like a
academic
tree.
tree.
The academic tree. The tree of knowledge.
Is it like a tournament?
Is it like a trivia question?
Every time
What is
we
actually
pass off,
count?
the
Is
kid
it like
else
math or
tries.
is it like a trivia question?
Or was like
It's
who's the 15th?
Or is it like
A
a
lot
mix
of
between
things
everything?
going on.
there's 3 rounds. There's like a category round where it's like all different types of categories like history and science. And
I would be a beast.
fine arts.
Oh, so it's like
It's
hard.
like slits.
Who's on
like a
Lake's math team or academic team?
You touch it and all the way. It's just
Anyone
The captain this year is Cooper Burchett.
Is it like middle school?
This is high school.
It's like
Is it like
a
an
All right, let's get back to math
Is
here.
it a tournament?
Stop asking me questions.
This last one.
Let's make an academic team out of this class.
This is the
Number
last
one,
one.
number one seed.
So we actually did 3
Bro.
seeds. I mean, I put it on the thing.
Yeah.
I know. Hoover was undefeated until the tournament.
Tree of knowledge.
I want
They
to
went down to the semifinals.
Are you the head coach?
The closer you are, the
You got no
you get.
It's girls, guys.
Coach of the year.
It's good.
You're
All
coach.
right.
Coach of the year.
Let's get back to math, shall we? See, the more time you waste, the less time you get on your homework.
But then I
What's that?
I just have a home to do it though.
Yeah, you just won't do it though. So we're talking about polynomials now. We had this idea of monomials. Now let's talk about polynomials. Now the prefix poly meaning many or multiple. Monomial means single. Polynomial means multiple. Okay, so that means I've got multiple terms going on. This is when I can put addition and subtraction in there and have multiple terms. 2 terms, 3 terms, 4 terms. Now, when you start adding in more terms, you can have more unique names. Like 2 terms is binomial, 3 terms is trinomial, right? 4 terms actually doesn't have a name. You just call it a polynomial. Remember that all of these are still monomials. A monomial is still a polynomial. It just has a unique name to it, okay? We're going to talk about the standard form and leading coefficient in a little bit. But right now, I want to just talk about what the degree of the polynomial is. When you talk about a degree of a monomial, you add up the exponents, right? When you talk about the degree of a polynomial is you take the highest degree. For example, look at each term of this thing. The degree here, okay, that's just 3. The degree here is just 2. The degree here is 1. The degree here is 0. You do not add them up when they're separated by addition or subtractions. You do not. You just take the highest one. So what's the degree of that polynomial? 3. Okay? So there's different rules to play by. Let's take a look at this next one here. Find the degree of the polynomial. Let's do something. Let's find the degree of each term, and then let's look at the highest one. What's the degree here? What's the degree here? 3. So what's my total degree? It's not 10. It's 7. When it's separated by addition and subtraction signs, when it's a you notice how this is 2 terms? We could call that a binomial, right? Still a polynomial, but we could call it a binomial. Because it's separated by 2 terms, we take each term as its own piece and then take the highest degree out of all of those. Okay, same thing here. What is the degree here?
2.
Be careful.
3.
3. Because that's a full single term, right? So the total degree here is 3. The degree here is 4. The degree here is 0. So what's the degree of this polynomial?
4.
4. The total degree of the polynomial is 4. Was that a C?
That was a hiccup.
Oh, was that?
That scared me.
Um, okay, what's the degree here? What's the degree right there?
6.
6. What's the degree here?
7.
Here?
No.
Here?
0.
So what's the total degree of that polynomial? 7. Okay.
So it's just like the highest number.
After you found each term. Yep.
Okay.
Yep. Okay, so now let's turn it over, and now we're going to talk about standard form. Now, there have been many times when people ask me, okay, does order matter here when writing it all out? And I've said, no, not at this point. Now, order matters. When writing answers in standard form, order matters. Basically, standard form is putting it in descending order in terms of its degree. Putting it in descending order in terms of its degree. So go from highest to lowest in terms of the degree. That's what we're looking at here. The standard form of a polynomial that contains one variable is written in the terms order from greatest to least degree. This is an example of something that is in standard form. You want to see why? Because the degree is 4, 3, 2, and 0. The degree is 4, 3, 2, and 0. Okay? That is in standard form. That is in standard form. That's an example that's in standard form. Now, we also have to talk about the leading coefficient. Again, the degree is a number. You know how to identify it now, but you have no idea what it means. You'll learn what it means later on. But for right now, we're just going to focus on identifying it. The leading coefficient is another number that you're going to need to identify, but again, you don't know what it means. You don't know the implications just quite yet. Okay, leading coefficient. It's exactly as the name implies. The leading, the first, the starting coefficient. The word coefficient means number multiplied to a variable. So in this case, 2 would be my leading coefficient. My leading coefficient would be 2 here. Okay? Again, you have no idea what it means right now. All you're focused on is identifying what it means. So the leading coefficient would be 2, the degree would be 4. Like for my purposes right now, since I know all of the implications of those things, I know that if the leading coefficient is 2 and the degree is 4, I know it's going to go up on both ends. I know it's going to go positive and positive in both ends. I also know that it is the possibility of having 4 zeros. I know that we'll have 3 turning points, so that a maximum value of 2 or 3 minimums or maximums. See, I know a lot of things based on the leading coefficient and the degree. You're not going to learn that just quite yet. That'll come later. So let's first start off by taking this into standard form, then giving the degree and the leading coefficient. So if I were to truly put this into standard form, what would be my first term? Anna?
9.
Biggest.
Oh, the biggest?
Biggest.
Then like the 7.
Yeah. Negative 7x to the 5th. And watch out there. Make sure you bring the negative with it. Yeah, the sign directly to the left of the term has to come along with it. Biggest to smallest. I like to cross them off as I go. Okay, so what's the next one? 4x to the second? Yeah. And then obviously my next term would be a 6x, and then a plus 9. Somebody asked me last week, why do we have to do this? Honestly, it's just a formality, just a way of writing them. Okay, but you're going to need to do that. Again, you'll learn a little bit more on the why a little bit later. Right now, it's just kind of like, trust me, you got to do it. Yeah.
Is a 6x exponent 0 or 1?
1.
Okay.
1. Yeah, because technically the degree of that term is 1. The constant would have a degree of 0. Now, it asks me for the degree and the leading coefficient. Now, the nice thing is when you put it into standard form, the degree and the leading coefficient should be very easy to see. What's the degree of this polynomial? 5. It should be the highest power on the far left. That should be your degree now. What's your leading coefficient? Negative 7. Negative 7 is your leading coefficient. Remember, the leading coefficient is always the number out front. Do not say negative 7x to the 5th. Leave off the x to the 5th. Correct. That is wrong. Saying adding an x to the 5th with it would not be the leading coefficient. If I just ask for a coefficient, I'm asking for a number. I'm asking for a singular number next to the highest power on x. Let's do that same thing again. What's my first term here? Danielle? Be careful. Highest power. Not smallest, biggest power. Y to the 6th. Y to the 6th. Then I can put my y squared. Then I can put my minus 3y. So what's my degree of this thing? 6. My degree is 6. My leading coefficient? 1. It's 1. Remember, I just talked about this. You're not paying attention. I just talked about this. The leading coefficient never includes a variable. By definition, a coefficient is a number multiplied to a variable. So what number is sitting out in front of the y to the 6th? A 1, not a 0. A 1. Okay. Let's take a look at the next one. What's my first term? X to the 5th. Oops, I put a plus. I guess that's not going to be all right. Next term? 9x to the 3rd. Now we bring down the minus 4x squared and our constant of 16 sitting out there on the end. Again, it's going to go in descending order, going down in terms of the degree. So what's the degree of this whole polynomial? 5. What's my leading coefficient again? 1. Good. Now, the reason we stress that is because there are certain polynomials that when you have a degree of 1, when you have a leading coefficient of 1, it kind of means something. Yeah, there's things that you can tell based off of that. Again, you don't know that right now, but later on you will be able to. Now, we've gotten to this point in the lesson. We only got 13 minutes of class left, and we haven't even talked about addition of polynomials yet. This title of this section is Adding and Subtracting Polynomials. And we haven't talked about addition yet? Oh man, it's going to take another day, right? No. You want to know why? Because essentially adding and subtracting, but we'll talk about that a little bit more tomorrow, adding of polynomials is just combining like terms. That's literally it. You guys know how to combine like terms? Yeah. You take same variables raised to same powers, and you add or subtract their coefficients together. Like for example here, what are my like terms? Oh, be careful. One of them's p squared. You can be able to add that p squared with the p to the thirds? No. Could I have multiplied it? Yes. But can I add? No. So here are my like terms. 12p to the third, 8p to the third. So 20p to the third. Don't say 20p to the sixth. That's not right. You're thinking about multiplication again. This is addition. Combining like terms. You don't change the variable when you're combining like terms. And then we bring down our plus 11p squared. Again, you cannot combine those two because they have to have the same variable raised to the same power when you're adding and subtracting. And when you add or subtract, you just add or subtract the coefficients, leave the variable.
Are we gonna have to multiply those on the test?
Section 7.2 is all about multiplication.
Okay.
Yeah. That's why we're going to spend a couple days on it. Let's take a look at example B here. T squared plus 2x squared minus 4t squared minus s squared. All right, so let's combine. I've got a t squared and a negative 4t squared. What's that get me?
Negative 3 squared.
Negative 3t squared. And then I've got a 2s squared minus s squared.
S squared.
Just an s squared. Yeah.
How did you get, like, wouldn't it be minus 4t squared?
This is a 1. 1t squared minus 4t squared. Just like this is a minus 1 here too. Last example on this one. 10m squared n. Oh, just put it in the box. Thanks. 10m squared n plus 4m squared n minus 8m squared n. Now the nice thing here is, are they all like terms? Yeah. 10, 4, and minus 8 gets me what? 6. M squared n. So that trinomial reduced all the way down into a monomial. Right? All right, last one here. Now, this may look different. The reason being is because it has parentheses, right? But all I'm really saying to you is all I'm going to do is add this trinomial with another trinomial. But essentially, are those parentheses doing anything? No, because I'm just adding. So this is essentially the same thing as this. Just going to kind of wipe those out. So I'm just going to combine like terms again. Okay? That plus in the middle of those two parentheses doesn't really do anything. Like, would I be distributing in a plus? No. It doesn't make sense. I'll have to think of a little bit more. I'll have to think a little bit more about that tomorrow when I do subtraction. But for right now, I don't need to think about that. So let's just combine like terms. Now, when you're combining like terms, your answers in every question on this test and this whole chapter should be in standard form. What does that mean? That means I need to go the biggest power first. 3x squared plus 5x squared. What's that? 8x squared. Positive 4x, positive 2x. What's that? 6x. And then plus 3 minus 1 is a plus 2. And that's my answer. Degree is 2. Leading coefficient is 8. It's got 3 terms. You can consider this a trinomial if you wanted to. Yeah.
When they give you those problems in the parentheses, are they already in standard form order?
Not necessarily. The second one wasn't.
Oh, okay.
You know, the second one had an x, then an x squared. So I guess they don't have to be in standard form, but you should put them into. Like these are both given in standard form.
Okay.
But, you know, you should just make sure your answers are always in standard form. Okay, biggest power on A is 2, right? The degree of 2 here and here. So what's negative 5 and positive 2? Negative 3. A minus A cancels. And then I got a plus 2 minus 9, so minus 7. Looks like that's a binomial. Leading coefficient -3, degree is 2 terms. Okay. Questions on that? All right, I'm going to turn off the video and then I'll hand back the quizzes. I am going to put up the